Okay, so with the polynomial arithmetic, we've started with multiplication. And we've multiplied monomial by monomial and monomial by binomial. Now let's take a look at a binomial times a binomial. And this goes back to the good old FOIL method, okay? Y'all have heard about the FOIL method before. You've done it. The FOIL method only applies to binomial times binomial multiplication. A lot of teachers nowadays, the neo teachers, they don't like the FOIL method, okay? Because it doesn't work everywhere. Okay? It doesn't work on a binomial times a trinomial. It doesn't apply to a monomial times a longer polynomial. But I love the FOIL method. Okay? Because when it comes to 9th grade through 11th grade algebra, we are constantly multiplying binomials. So it is a great tool for binomial multiplication. First, outside, inside, last. Okay, moving on from binomial times binomial. Here's another one. Again, this is not complicated. This is not new. This is old stuff. So you see that we end up with 4 terms after the binomial distribution. And then we can simplify those 2 middle terms. And we end up with in this particular problem, a quadratic trinomial. If you were asked to name this thing by degree and number of terms, you would say it's a quadratic and it is a trinomial. I will. Because the multiplication follows right along with what we were doing yesterday with laws of exponents. Okay? So now let's go back and let's talk about addition, subtraction of polynomials. And we'll have to go to okay. So now when we are adding and subtracting polynomials, instead of dealing with exponents and adding exponents and all that good stuff, we don't have any of that. You just combine your like terms. If 2 numbers are the same, in other words, the combination of variables are the same, you can put those together. Very easy. So you're just combining like terms. So if I see x and x, I put those together, I get another x. So 4x plus 5x equals 9x. Like terms are those with the same variable combinations. This is all old stuff. If I don't have the same variable combinations, I cannot combine those through addition, subtraction. Okay, here's another example. We're adding. The example's already been completed. You see how I've canceled out. What I like to do is as I combine like terms, I like to cancel those out so I don't have to think about those anymore. So I had a 2x squared and a negative 3x squared. Notice I'm adding these 2 polynomials. These are trinomials. I'm adding the 2 trinomials. So I look at the parts that are the same types of variables, and I put those together. So 2 minus 3, negative 1. Do I really need to put the 1 there? No. So that gives me negative x squared, and then negative 15x minus 12x is negative 27x. And then 7 minus 8 is negative 1. So I've got a trinomial answer. Okay, so we are subtracting these polynomials. Notice that I've got both of the polynomials inside parentheses. But in reality, only the second polynomial really needs to be inside parentheses to make things clear. So since we are subtracting each part, we have to do what Zara said, change each sign inside that parentheses. including the sign outside the parentheses once you've done all the changes. And this is why we do that. It's as if I am multiplying by a -1. So what happens when you multiply by -1? You change the signs, make them negative, make them opposite or what they are. That's why I'm changing the signs. So I'm going to go ahead and change all the signs, including the one on the outside or in between. All right, so having done that, now it's just addition. If you are careful enough to change the signs, that's it. It's not that people don't know how to do these problems, they're not careful. So combining like terms gives me, I've got xy squared. Is there an xy squared over here?
Yes.
Yes, right here. So we got 13 minus 11. And those are done. All right. Then I've got x squared y. -14 plus -12. -26. When you add negatives, you get a negative.
And then it's. Are you changing the sign for the whole back?
The whole back part have the signs changed.
Plus 9.
All right. So then 7 plus 2 is 9, and there it is. Okay. Okay, so we will change our signs.
So it'll be plus 2y.
Plus, or it'll be minus 2y.
Oh, it was. Never mind. I messed up already.
What's the answer?
It's a ball.
So minus 2y minus 16x squared plus 5, and don't forget to change the sign on the outside as well. All right, let's see here, honey. Houston, we have a problem.
He just said you saw.
All right.
My boy.
Okay, so 4x squared. Is there another x squared?
No, sir.
Yeah. All right, so we got -12x squared.
I thought it meant y.
So now
Alright.
it'll be y squared.
No, but 3y squared minus 2y.
Yes.
Okay.
Plus 4.
I mean, minus 2y
Plus 4.
Good. All right, now let's talk a little bit about the order of these exponents. Okay, this is not something I talked about yesterday, but it's a good thing to know. There's something called descending order and ascending order. Ascending order is when I'm going up. Descending order is when I'm going down. We're going to list if possible, we're going to list our polynomials in descending order according to the exponents. Now, here, these got the same exponent. So it doesn't really matter. I don't care which one you put first. And if there was like a x squared y right here, I would want to put the x squared y first because it has a higher degree. Basically, you're going from the highest degree down to the lowest degree. Okay? And those that were not here yesterday, you really need to watch that video because we talked about how to determine the degree of a polynomial based on when there's more than one variable in that monomial. Okay? All right.